Machado, and I run a laboratory at the University of Otago, just next door. I'm in the Department of Psychology, and I also, sorry, I got a pointer here too, and I'm also the director of the neuroscience program at the University of Otago. And I'm here to talk to you a bit today about what kinds of things might we do to maintain higher level cognition as we age. So it's well known now that as we grow older, it's just a fact of life that our cognition will decline a bit. That's a natural thing that occurs as we grow older. And I'm going to talk about some things we can do. But before I do that, I just want to give you a little bit of information on my background. So I started out many moons ago, about 30 years ago, studying cognitive psychology at UCLA in Los Angeles, and trying to understand how cognition works in healthy brains. So how is it organized in the brain, and what are the mechanisms that support it? And then I went on to do some PhD research in Northern California, and then eventually a postdoc in the UK, working with neurologists to try to understand, okay, now that I understand a bit about cognition, what happens when you damage the brain? So what are some of the changes that occur after you've damaged the brain? And I did that for 8 years or so before I came here to the University of Otago in New Zealand. Just to give you a couple of examples around that, this is brain scans with a cut like this through the brain of somebody who had a stroke. And you can see some damage here. Oh, sorry, this is a coronal cut up there. Sorry, you won't know what that means, but that one's that way. And the one down here is the one that's that way. And basically the damage you can see here is at the back of the brain. And the problem that this person had was quite straightforward. They were unable to see. So they were unable to see for part of their visual field related to this damage here. So sometimes you have quite straightforward deficits that are reasonably well understood. In other cases, this is more forward in the brain, in part of the frontal lobe. And these patients, this is a number of patients who had damage to this region here, which is also indicated here on this horizontal brain cut. And in this case, the patients could see fine, but they had a lot of trouble controlling what they looked at. So they had more of a higher level cognitive problem that is not as straightforward in that they can see, but it still impacts quite significantly on their daily activities because they don't have the level of control over what they're looking at that they used to have before they had the stroke. So that just gives you some ideas of the kinds of things that can happen after having a stroke. And unfortunately, even if you age healthy and you don't have any neurological difficulties as you grow older, it's also true that the brain will decline. So that's just a normal part of aging. I have here 2 different brain scans. There are scans that are cut like this. And one of them is a young adult brain, and one of them is an older adult brain. Can you tell which one you think might be the older adult brain? Yeah, does someone want to shout out which one's the older one?
Left.
Got a little bit of a mixture there. I did hear the right, a number of people did say the right. Oops, sorry. Yeah, this one on the right is the older brain. And I wouldn't expect somebody who hasn't looked at brain scans before to notice, but what you see here, if you're used to looking at them, is you have these cavities deep in the brain on both sides, and they're called the lateral ventricles, but it doesn't really matter what they're called. In this young adult brain, there's lots of brain tissue, lots of tissue volume, and it's pressing hard into those cavities that make them look really small. In this older brain, the tissue's deteriorated more of the brain, and it's not pressing so hard into the cavities, so they start to look a bit larger. That's just a normal part of growing older. And with that, you see other changes as well. So not only is the tissue deteriorating a bit, even with healthy aging, but you also see changes in brain blood flow. So blood flow to the brain, which is really important in terms of supporting cognition, and I'll talk a little bit more about that in a second, declines as we grow older. So here you have blood flow. Hotter colors indicate higher levels of blood flow. And here you have a young adult brain where you see a bit more of the yellow and reds around. And then you have a middle-aged brain, and then finally an older brain where you see a little less of the hot colors, and that's just a normal, natural decline in blood flow to the brain that occurs with healthy aging. And in addition to the reductions in blood flow, we also see some changes in responsiveness to changing needs not being quite as good as it used to be. So when you start thinking, for example, your brain cells start firing and they need some supplies in. So they need more oxygen and nutrients to help them maintain that high level of firing that's supporting your thinking. So when you think you actually have a lot of activity going on and you need some blood supply in there to help with that. And as we grow older, it's normal that that response is not quite as good as it used to be. So you don't get quite as good supply to support your brain cells firing as you used to when you're younger. And similarly, you don't respond quite as well in cases where you are exposed to higher levels of carbon dioxide and you're wanting your blood flow to speed up to get more oxygen in to support your brain cells. And with this come some changes in cognition. So what you see here is examples of an easy task, and then a bit harder task, and then quite a challenging task, so the task is getting harder. And if you compare performance in young adults compared to older adults, what you see is the difficulties the older adults have gets larger and larger. So it tends to get harder and harder as the task gets easier. So not as much of a problem for a really easy task, but as the tasks get more and more challenging, sometimes older adults have more difficulties. And along with that, what we also see is some changes that occur in terms of blood flow. So whereas young adults might be using areas here, older adults will use those areas and also some more areas that are closer to the forehead to try to support cognitive performance. But despite that, we still see some declines occurring that are just a natural part of aging. So that's sort of the downside of aging. This is kind of just a quick summary of that. So basically, this is when you're a child. So this is age going up. And what you see in terms of general cognitive performance, it's improving up until your 20s, maybe your mid-20s, depending on the type of task. And then you see it starting to decline slowly. And that's the realities of growing older, and what we're going to be talking about today is what are some of the things we can do to try to improve that trajectory. So some of the things we said, I've only gone into this area of research about 10 years ago. I spent quite a lot of time trying to understand cognition and things that go wrong. And then over the last 10 years, I started to think about, okay, what can we do about this? What are the things we can do to try to improve cognition? And we started out looking at exercise. So engaging in physical activity, might that be a way? And I'll talk about some of those results. And we also tried a nutritional intervention where we had people eating healthier nutritional content than they normally did to see if we can improve their cognition. And we were able to receive funding for some of these projects from Brain Research New Zealand and the Neurological Foundation of New Zealand. And I'll talk a little bit about some of the results. Now, I'll just point out that this research is very interdisciplinary. I'm the cognitive person on the team, and I work with people depending what we're looking at. For example, a blood flow expert in the UK who will help with the vascular side of things, understanding the brain blood flow dynamics. I work with human nutrition experts, with psychiatrists. I work with a statistics expert from Sweden. So it's always quite a team effort. And the overall thing that we're trying to work on is basically just improving that trajectory. So making the downward thing that happens normally with aging just a little less steep. So if we can perform a little bit better cognitively, that means we can enjoy our older years more. We can enjoy our day better, have a better time with our family, and feel better about ourselves. So one of our early questions was, might it be the case that if you engage more regularly in exercise, that you can improve brain blood flow and improve the way that your vascular system in terms of supplying blood to the brain is working, and then with that, improve your cognitive performance. And when we set out looking into this, although what you saw here, this is my colleague in the UK, used to be here at the University of Otago, and he's on an exercise bike. But what we actually ask people about is not how often they cycle specifically, but just general exercise. So that could be anything from intense exercise like climbing a mountain or engaging in a marathon or something, or just going for a walk. So just a brisk walk. And actually what we found, this is just a heads up, is that the relationships were not actually restricted to higher intensity physical activity. So the positive relationships we saw in terms of benefits were associated with things like brisk walking too. So it's not necessary to think that you would have to do something highly intense in order to gain some of the benefits. And of course, everybody's different in terms of their fitness levels, but the idea would be that if you do something that gets you breathing a little more heavily, gets your heart rate up a little bit, then that's likely to be giving you benefits. And so what we found in our first 3 studies is that, that people who are engaging in more physical activity, including brisk walking, perform better on the cognitive tests. And that was particularly true for the tests that are more challenging. So I mentioned that we had a really easy test. In fact, I can quickly show you what they look like. This is a very easy test where all you have to do is press a button on the same side that the green square appears. So you're pretty much just looking at something and then generating a response that's quite automatic in its nature. It's not challenging at all. Just pressing on the same side of a green square. And then a bit of a more challenging task, now the square is always going to be red and you have to press on the opposite side. So people have to suppress the natural reaction of pressing on the same side and instead press on the opposite side. If you accidentally press on the same side, that's counted as incorrect. So people tend to find this a bit more challenging because it involves a lot more cognitive control processes to get the response correct. And then finally, for the most challenging task, it's a mixture of green and red squares, and I'm guessing a few people in the audience probably participated in this. And there's a mixture of green and red squares, so you press on the same side of green squares and the opposite side of red squares, and again, you're trying not to make any mistakes, so if you find it a bit challenging, you're likely to be a bit slower in doing it, and you might make a few mistakes. And these are the kinds of tests, particularly these more dynamic tests where you have to have a high level of flexibility, that we tend to have a bit more difficulty with as we get older. And so what we found was that people who exercise more regularly perform better, particularly on that last most challenging test, and also a bit on the one that's a bit easier, but not the really easy one. And in addition to that, they showed better vascular functioning. So for example, they had more oxygenated blood in the brain, and they also had a better responsiveness to changing demands, so that their blood flow system to their brain was responding better to changing conditions, which is exactly what you want, because thinking is quite dynamic in its nature, and so you need your blood supply system to be able to respond dynamically to those changing needs as you start thinking, and be able to get to your brain what it needs in order to support that thinking. So the sort of upshot of that was, well, if you're a bit of a couch potato, you might end up with your brain not in such an optimal physiological state, whereas if you exercise regularly, but not necessarily speed cycling, it could just be a brisk walk, or anything that can help get your heart rate up a bit and get you breathing a little more heavily, then your brain might be in a more physiologically better state, plenty of oxygen available to support your cognition or thinking skills. Okay, so then we started to ask, okay, well, it looks like exercise is pretty important when it comes to cognitive functioning and the general functioning of the brain. So we started to ask, well, how are New Zealanders doing with this? And Haley Guinea, who did her PhD in my laboratory, analyzed some nationally representative data from New Zealand, specifically focusing on people aged 60 plus. And the first question she asked was, all right, well, how many people aged 60 plus in New Zealand are meeting the physical activity guidelines? And the recommended guidelines, in case you're not aware, is at least 30 minutes, at least 5 days a week. So what percentage would you guess might be meeting those guidelines? I mean, really, you want it to be as close to 100 as possible. It's at least 30 minutes, at least 5 days a week, but we're actually at less than half, 46.2%. And sadly, for me, just because I happen to be female, It's even worse for females than males. So we have a long way to go. I'm not saying we can necessarily get this number up to 100. There might be a number of reasons why people aren't able to engage in physical activity, or that the type of physical activity they can do might be limited, but I think we can do a lot better than this number here. And unfortunately, if you look across the 2 years, so she was looking at the data from the 2012 and the 2014 survey, and if you look across the 2 years, do you think we got better or worse? I was kind of hoping better, because it seems like you hear on ROZ all the time, get out there and exercise, but it did get worse. It's actually quite a big drop, from 53% down to 40%. So we really need to change that trajectory and get people more active, I think. Although I will point out, it's not only physical activity that you can do to try to improve your brain function. So some of the things we tried to look at, it's known now that consuming beetroot can have positive effects on your blood flow system, that can have positive knock-on effects to your brain functioning. So we ran a study, and some of you might have participated in this one too, where we had people eating purple bread, beetroot bread, and unfortunately it can be quite difficult to get people to adhere to a diet. Maybe especially if it's purple bread, I'm not sure. but the research does clearly show that beetroot can have positive effects on your blood supply system and also on your brain functioning. We also tried to reduce sodium, so it's also known that if you reduce your salt intake, that can have positive effects on your blood supply system. And also nuts. Nuts such as walnuts, and in this case we tried hazelnuts, which also have a positive effect on the integrity of your brain. It's beneficial, the types of fat that it is beneficial for your brain cells. So we've done a little bit of research on this, but we do have a long way to go, just because it's quite hard to get people to adhere to dietary changes. People tend to like to eat what they like to eat and don't necessarily like to change it. So we've got a little bit more work to do on that. But of course, many thanks to the Neurological Foundation for what we've been able to figure out so far. Oh, and I just wanted to point out another thing that you may already be aware of is that depression and anxiety, negative mood states you might say, can have a negative impact on your cognition. But you might have heard that if you engage regularly in exercise, for many people that can improve your mood and put you into a better state that can also have positive knock-on effects for cognition. So that's just another thing to think about. Some of the other things we thought about, and other labs around the world have thought about is, okay, is cognitive functioning like a, use it or lose it kind of thing? So can we train our brain to work better on a cognitive level? So we've looked at relationships between cognitive engagement and how you're performing cognitively, and I'll talk a little bit about that. Social activity, there's data out there suggesting that regularly engaging, just meeting up with friends and having social interactions can have positive effects for cognition, so we've got to look at that as well. And bearing in mind that sometimes when you get together with friends, you either learn a new challenging game, so that might be a new cognitive skill that you picked up meeting with friends, or you might have talked about politics or science or something going on that challenges your brain a bit too. So that can be part of the positive aspects of social engagement. And then, of course, sometimes you meet up with friends and engage in physical activities, so you can combine these things nicely. You might meet up with a friend go for a jog or a brisk walk, and that can also have dual benefits for your brain functioning. And so Haley Binney, who I mentioned in her PhD in my lab, she finished last year and received funding from Brain Research in New Zealand. She ran this large study over a couple of years where she was looking at volunteering in New Zealand, specifically in the Dunedin area, and specifically also in older adults or people aged 65 to 75 years old and have already been retired for at least 6 months. And what she was interested in is looking at, so this study's finished now. She was looking at, I'm sorry that the text is a bit small, but I'll walk you through it. She was looking at people's volunteering habits, so just volunteering in their community, and relationships with cognitive activity, social activity, and physical activity. So depending on the type of volunteering you might do, sometimes it involves learning new skills. So activating the brain and training the brain, you might say, in terms of learning something new. Sometimes it involves social activity, where you're meeting up with people or visiting people. And sometimes it involves physical activity. For example, you might be walking around neighborhoods, meeting people, or helping people in some way. So it might involve an increase in physical activity compared to what you normally do. And all of those things are understood now to have potential positive effects on the brain in terms of neurological health and also mental health. And the idea there is that you may then have positive knock-on effects for cognitive functioning. And what she found for the people who participated in her study was that the types of volunteering they did were associated with increases in cognitive activity and also social activity, but not physical activity. That's just the types of volunteering people happen to do. And those increases had some relationships with better cognitive performance, as did physical activity, but since that wasn't linked to the volunteering, it wasn't really relevant specifically to the study, which was focused around volunteering. So she was able to see some relationships in terms of regular volunteering being associated with better cognitive performance, although we were quite keen to be able to see this relationship too. So we decided to change tactics a little bit and do something a little bit more proactive. So in the interim, it became increasingly clear that physical inactivity, so not engaging in much exercise, is one of the most common preventable risk factors for both Alzheimer's disease and stroke. So for us, we thought, okay, this is something really important that we need to address and hopefully be able to understand better what the relationships are between physical activity and brain functioning. And it also became more clearly known that higher physical activity levels are associated with reduced risk of Alzheimer's and stroke. So really worth investigating. And so we asked, okay, going back to the survey data in New Zealanders, specifically age 60 plus, all right, what percent of New Zealanders are inactive? And when I say inactive, it's really quite a small amount of physical activity, just less than 30 minutes total per week. So that means you're really not engaging in much physical activity at all. And if you look amongst New Zealand older adults, unfortunately it's over 20% are engaging in less than 30 minutes per week. And then, as per last time, we looked, okay, well, are we getting better or worse? Looking from 2012 to 2014. And again, worse. So more older adults in New Zealand were engaging in less than 30 minutes physical activity per week in 2014 compared to 2018. So again, the trajectory is not great. We decided to go ahead and do a more proactive intervention. So now what we decided to do, and actually one of the people engaged in this research is here. I do need to touch this. We decided to start in young adults, university students, and try getting them to exercise more while they're actually at the lab, and then we could test their cognitive functions and their mood states afterward. So we had them running up and down stairs, not for long periods. The total amount of exercise was just over 10 minutes for the entire thing, but it actually only involves 3 one-minute bouts of running up and down the stairs. So they run up and down stairs for 1 minute, and then they walk on flat ground, and run up and down, so it's a bit of a warm-up, run up and down, run up and down. But it's really only 3 minutes of intense exercise. And the question was, well, after doing that exercise, might we see cognitive benefits? And what we found was, yes, there were some cognitive benefits. Not quite as strong as we were hoping for, but there were significant improvements in the cognitive functioning. And it was specifically tied to the more challenging tasks, the types of tasks that we tend to have more difficulty with as we grow older. So that was encouraging. And in addition to that, the mood benefits were actually quite massive. So people felt way more energetic after climbing up and down stairs compared to another visit where they didn't engage in exercise. And they also felt less tense. So we were feeling pretty encouraged about that. But at the same time, we thought, well, maybe we can get them just a little bit higher. So the cognitive benefits weren't as good as what we were hoping for. So we thought, okay, well, let's see if we can improve on this and have them engage in a little more exercise. So then during this last year, rather than having them engage in only 3 1-minute stair climbs, we had them engage in 6. And what you see here is their heart rate, and you can see it's going up nicely with 3, but it goes up even more and stays at that higher level with the 6. And so what we're hoping is with the 6 1-minute stair climbs, it's still not an enormous amount of exercise. We're still only talking about just over 16 minutes, so not a huge amount of time investment. And what we found was the cognitive benefits were much more robust. So people perform much better after doing the intense stair climbing. Again, only 16 minutes of it, but still it was more intense, particularly for the more challenging tasks. But when it came to the mood, those benefits were actually much less robust. Perhaps not surprisingly, you might feel a bit knackered after running up and down stairs for more times. People did still feel more energetic, but not to the level they had after only doing the 3 1-minute stair climbing. And they also felt happy after doing the stair climbing. So all of this was very encouraging, and fortunately, Brain Research New Zealand funded Jordan to trial this in older adults. Now, we of course had to be very careful, and not everybody is able to run up and down stairs, but quite a few people did volunteer, and a number of them were able to do it. So we had over 70 people interested in doing it who volunteered, but if they were on blood pressure medication, for safety reasons, we weren't allowed to test them on it. So that was actually a lot of people. But nonetheless, sort of nearly half, a bit less than half, were able to actually participate. And we're just analyzing the data now. So the data collection finished this week, and we'll now go into the data analysis phase, so I can't tell you yet what happened. But I am kind of curious to know, when you think about if you're age 65 plus, when you think about it, it's like, wow, would you feel comfortable doing that? Yeah, a lot of people might not. And maybe there could be a better option. Now, you might say, well, why would you pick stair climbing? The reason why we picked stair climbing is because we didn't want to have something that's easily accessible. So in order to be able to test people, so this is the stairwell within the building, and then you can test them right afterward. We don't have a steep hill in the lab kind of thing that people can use instead. So we're still kind of working on, we wanted to use something also that people could in theory continue to use, so not something that involves expensive equipment or something that they wouldn't have at home, so they obviously couldn't do it. So we didn't quite hit on the perfect thing probably for people age 65 plus, but we're still working on it, and if you have a great idea on this, please let me know. And hopefully we'll still see benefits, but we're aware that, well, there were a lot of people who couldn't do it, so we want to come up with something else that is more suited to people in the age 65 plus range. So I'll just remind everyone that there's quite a lot of things you can do to try to boost your cognitive functioning. The things I focused on today were centered around regular exercise. This is Peter Chen, I don't know if anyone remembers our mayor. He couldn't ride a bike, so he was on the back. And also healthy food. So good intake of healthy food can help. And one of the things we're working on next is trying to pull some of the things we found so far together. So pulling together this idea that exercise puts your brain in a more optimal physiological state, supplies more oxygen, and can get blood flow going. We're thinking about combining that with some targeted low-level electrical brain stimulation, which can help get the blood flow specifically to that area here near the forehead that I talked about older adults are using, that young adults aren't using, and that seems to be helping their cognitive performance. And we're going to see if we can, by having a more targeted approach at that area, whether we can boost cognition even further beyond just exercising on its own. And I just want to thank everyone for coming. I want to thank all of the participants. I know some of them are here. Needless to say, the research couldn't happen without them. Many thanks to all of our funders. You can see the icons here. And of course, to all the students who have conducted the research as part of their research degrees. So thank you very much, everyone, for coming. And of course, thank you to the Neurological Foundation and to the museum for holding the event, and to Jack and Kelly for helping me with organizing all this and for inviting me. Thank you all very much.